Theivanai Ammal College for Women. Learn, live and lead.
Myself, Dr. J. Silambarasan, Assistant Professor, Department of Chemistry, Theivanai College for Women, Villupuram. So, I am going to present the topic quantum theory and electron structure of atoms. Wave theory of light. Generally, electromagnetic spectrum consists of many different types of radiation. In 1900s, James Clerk Maxwell, who showed that light is an electromagnetic wave that travels through space at the speed of light. So, generally light is composed of particles is called photons. The wavelength range of light between 400 to 750 nanometer is visible to the human eye, which is called the visible region in electromagnetic radiation. Other familiar forms including radio waves, microwaves, X-rays also present in the electromagnetic spectrum. Type of electromagnetic spectrum. Figure shows the electromagnetic spectrum is the range of frequencies of electromagnetic radiation and their respective wavelengths. When you hearing your radio or watching TV or send a text message or in microwave oven, so you are using electromagnetic radiation in every hour and every day. From the figure, the frequency may be defined as number of waves that passes a particular point in a second, and wavelength defined as a distance between identical point on successive waves. So, next, the light of frequency is relevant to its wavelength according to the following equation: nu equal to c divided by lambda. Here c is the speed of light equal to 2.9979 into 10 power 8 meter per second, and lambda is the wavelength and nu is the frequency. Next, the quantum theory of radiation. In 1900, physicist Max Planck presented a quantum theory. According to this theory, radiant energy is emitted or absorbed discontinuously in the form of tiny bundles of energy known as quanta. Each quanta is associated with a definite amount of energy E equal to h nu. Here h is the Planck constant, nu is the radiation of frequency. A body can emit or absorb energy only in whole number of multiples of quanta, that is 1 h nu, 2 h nu, 3 h nu and so on. The Bohr model of a hydrogen atom based on some important assumptions as follows. The electron continue revolving in their respective orbits without losing energy, that is stays in the same orbit. Second, the energy is emitted or absorbed by an atom only when an electron moves from one level to another. The angular movement of an electron moving around the nucleus is quantized. Next, atomic line spectra. This figure explains the examination of atomic spectrum of hydrogen with a spectroscope. So, next figure shows the 4 lines in the visible spectrum of hydrogen was named as Balmer series. Next, line spectra of hydrogen atom. After studying the wavelength of the observed lines, the Balmer was able empirically to give an equation which is further developed by Heisenberg. The equation is given below: 1 by lambda equal to R infinity into 1 by N1 square minus N2 square. Here the N1 is the first spectral line and the N2 is the second spectral line. Based on the Bohr postulates, he was able to calculate the energy of moving electron in different orbits around the nucleus in hydrogen atom. The equation is En equal to 2.18 into 10 power minus 18 into 1 by n square. As the electron gets closer to the nucleus, the energy becomes larger and more negative. In ground state, the lower energy state of an atom. Excited means each energy state in which n greater than 1. Next, the wave mechanical concept of atom. Bohr could not explain why electrons were restricted to fixed distance around the nucleus. In 1924, Louis de Broglie reasoned that if energy can behave as a particle, then perhaps particle could exhibit. So, de Broglie proposed that electrons in an atom has a dual character both as material particle and as a wave. So, de Broglie derived an expression for calculating the wavelength of a particle of mass m moving with velocity u, according to which the relationship is lambda equal to h by mu. Next, the quantum mechanics. The classical mechanics is obeyed by macroscopic particles such as planets and rigid bodies. Since the microscopic particles such as electron, proton and molecules shows a wave particle dual character and obey quantum mechanics. So, scientists aimed to understand exactly where electrons are in an atom. The HEISENBEG uncertainty principle described the position and velocity of an electron. So, HEISENBEG equation disproved Bohr's model of defined orbits for electron, and Schrödinger derived a complex for mathematical formula to incorporate wave and particle characteristics. So, quantum mechanics limits the accuracy of certain measurements because of wave particle duality and resulting interactions between the target and detecting instruments. So, HEISENBEG uncertainty principle states that if it is impossible to know both the momentum and the position of particle at the same time, maybe it can be explained by the following equation: del x into del p greater than or equal to h by 2 pi. For example, considering an photon incident on a particle which has a reasonable size, its position and velocity will not be altered by the impact of light photons, but in case of electrons, size is extremely minute. After the impact of light photons may be quite different from the original path and velocity. So, next, quantum numbers. So, each atomic orbital in an atom is characterized by a unique set of 3 quantum numbers. The first one is the principal quantum number, second angular momentum quantum number, third magnetic quantum number. So, principal quantum number explains the size of the orbital. The larger the n value, the greater the average distance from the nucleus. The angular momentum quantum number or azimuthal quantum number explains the shape of the atomic orbital, its value ranging from 0 to n minus 1. If L value equal to 0 means it represents the s orbital, if 1 means p orbital, and 2 means d orbital, and 3 means f orbital. Magnetic quantum number describes the orientation of the orbital in space in terms of x, y and z axis. So, this value equal to minus L to 0 to plus L. Electronic spin quantum number describes the spin of an electron that occupies a particular orbit. The value ranging between plus half and minus half. The electron will spin opposite each other in the same orbit. Atomic orbitals. So, the image shows the shape of, we already know that 4 orbitals, namely s, p, d, f. So, we can see s orbital is spherical in shape and p orbital has 2 loops on opposite sides of the axis. D orbital has more variation of loops and f orbital have complex shapes. The electronic configuration, Pauli exclusion principle. So, no 2 electrons in an atom can have the same 4 quantum numbers. So, according to the alpha principle, electron fill according to orbital energies, that lowest to highest. But the problem with this rule is that it does not tell about the 3 2p orbitals and the order that they will be filled in. Next, the Hund's rule. Before the double occupation of any orbital, every orbital in the sublevel is singly occupied. For the maximum of total spin, all electrons in single occupancy orbital have the same spin. Next, the rule for writing electronic configurations. The electron stays in orbits of lowest possible energy. In an orbit, maximum of 2 electrons will be occupied. Electrons do not pair in degenerate orbitals. The orbitals fill in order of 1s, 2s, 2p, 3s, 3p and so on.